look at the leftmost digits to be dropped. Okay, let's say we have 1.2 sorry, 151. Okay, we'll give this example, so let's move on. 1.2151. Look at the digits to be dropped. Leftmost digits to be dropped. Leftmost digits to be dropped. All right. 1.2151. Let's even take it to let me see, the three significant figures. Okay, let me just make this short, save time. Three significant figures. All right, 1.2151. Now look at the leftmost digits to be dropped. We know that it's okay. Three significant figures. We know that we can only have this at the end. Okay. So the three significant figures, we can only have this at the end, not this answer to be exact, but we have this type of answer to three significant figures. Okay, so now what we consider is if this digit to be dropped, this one is greater than 5 or is 5. Okay, we add 1 to the last digit to be retained. Okay, so like you're doing a mechanism. So okay, 1.2151. Okay, okay, so like I said, this is the important one. Is the important one we should so now leftmost digit to be dropped is 5. All right. Okay, if this digit is 5, okay, it's 5, and we need to round it off to three significant figures, like we're drawing a mechanism. Now this number is even, so we take 1, we add 1 to this place. All right, so we get to 1.22. all right, okay. But if we have a scenario whereby we have something like this, we have 1.2251. okay, this is the ones to be retained. Okay, the rightmost digit to be retained is this, is 2, and this one is to be dropped. But in these rows, this is even, so 1 can be added to this because 5 is odd, because 5 cannot take 1. So that one of the rules of rounding off. You can't take 1 from 5 and add it to 2. No. So only if you have like 1, 3, maybe 5. Okay, we can have 1.2, 1.22, 1.24, and 1.26. But 2 years even. If you have 2, even if you have 4, use 4, it still remain the same thing. Okay, so 1.22. Okay, 1.22. Alright, okay, 1.22. So rounding off, we get 1.22 also. Okay, because this is even. All right, so I think rounding off is it depends on the number of figures you want to get, significant ones, and also if, let's say, we have little less than 5. Let's say we have 4. We have 4. We still give the same thing. If you have 3, you have 3, you get the same thing. Alright, so this, if it's less than 5, you get the same thing. Okay, if the digit is greater than 5, okay, and it is 6, 7, 8, 9. You can round it off also. Okay, now let's see, we have 1.2. Uh, 1.22. Oh, let's put 1.21. So explain. Let's see, we have 6, 4, 5, 3. Okay, we start from here. 3 is out. 3 is out. Okay, 5, 4. 4 is even. So 5 cannot add 1 to this. So 5 is out. Okay, 4 cannot be rounded off. So 4 is out also. Well, 6 adds 1 to this. So you have 1.22 also. Okay, okay, let me put a more example to give. Okay, that's basically just rounding off. Right. No, we have let me retreat this. Let me retreat it so you don't forget. Alright, we have 1.2. Okay, let me change. So let's see, 4.656679. I take it to 3 significant figures. Okay, so this adds 1. No matter what, it's still greater than 5. So it adds 1. Okay, this adds 1. This adds 1. So it's, so you have 4.66. Alright, these figures are greater than 5, so they can be rounded off. Okay, remember, if the figure is less than 5, 4, it can be rounded off. Okay, 4 is out. So, and we have 4.65. Right, so if we have 1. Okay, we have 1.2165. Okay, 6 is even, so 5 cannot round it off. Cannot be rounded off. 5. If it to be 6, or let me see, if it to be 6, if it to be 6, then 6 could have rounded it off to 7, so it could have gone this way. 1.217, 1.22. Okay, but rounding off, since this is 5, this is 5, you can round it off, so 5 is struck out. We have 1.216, like you're giving a pathway. This adds 1, so you have 1.22. Okay, remember these rules, remember these combinations, remember these guidelines, and you'll be fine. Okay, so that's that rounding off. So we go to the last part of errors. You have the maximum and the standard errors. Okay, whereas the rules of combination of errors. Okay, so let me see this will be different. Let me take blue. Rules of combination. Combination of errors. Okay. Now we have the maximum and we have the standard. Alright. We have the maximum and we have the standard. So maximum, okay, 1. Let me hit maximum error, standard error. Okay, you know this symbol is E and this delta. Okay, you have the maximum and the standard errors. Okay, so these have different rules of combination. Okay, for maximum errors, the absolute or relative errors, as the case may be, anyone, absolute or relative. Okay, so we can have a textbook saying absolute, or you can have an exam saying relative. It means the product, absolute. Relative errors for products, okay, quotients and powers. Okay, I'm gonna do the maximum errors. Okay, let me make this clear. So I think for the standard with maximum errors. Okay, the absolute errors, as the case may be, they are added. Okay, you have everything added. All right, so let me see. Let's see, we have add subtraction. You see added, they are added. Where we have they are added. Whether we have quotients, powers, and what else? Quotient, powers, and products. Alright, products. Whatever the case may be, they are added. Maximum errors. Whatever the case may be, they are added. Now for standard errors, in place of simple sum, we have root sum of squares. Alright. In place of simple sum, instead of adding them, we have the root sum of squares. Okay. Root sum of squares. I'll explain further when we get. Okay, so in case of maximum errors, they are added. We have quotients, powers, products. For maximum errors, the absolute or relative errors in case of products, quotient and powers are added. Alright. Whether we have quotients, we have powers, we have products, they are added. The standard errors, in place of simple sum, instead of just adding them and forgetting about it, we take the root sum of squares. Okay. So let's look at 2 cases or more. Okay, you have case 1. We have the addition and subtraction. Okay, let's say we have Z. So A minus b plus c. Okay, now we have is the root equation. Now for maximum error, take the maximum error of this. Okay, we just simply we do we just do error in z equals to error in a plus error in b plus error in c. Okay. Okay, well this connotes the errors in a, b, and c. Alright, error in z also. Okay, so that's for maximum error. Alright, so for standard error, okay, so we have, like I said before, is the root sum of squares. Standard error in z, that is okay, I don't mind writing. Standard error in z, okay, we have, see, root sum of squares. Z square equals delta a square plus delta b squared plus delta c squared. Alright, that's for standard error. In case of addition and subtraction, this just add them, just add the errors in the maximum error. With standard error, standard error in z, we do this. The root sum of squares, the sum of squares of everything. The errors in z, errors in a, b, and c. A, b, and c. Alright? Okay, so that's that. So look at the second case. Okay, let's look at case 2. Let's take a look at case 2. Case 2. Okay, so make a difference. Multiplication and division. Okay, multiplication and division. All right, let's say we have z equals a multiply b over c. Okay, one for maximum error. Okay, for maximum error. Now remember, for maximum error, we just take the sum. Standard error, we the root sum of squares. So for maximum error, we have e z of z equals e a over a. That's error in a, and error in b over b plus error in c over c. So that's just it. Okay, so this is the formula. Whatever you're given, take the maximum error, a multiply b over c. Alright, a multiply b over c. So just do it like this, and you're good to go. Okay, for standard error, this is pretty much like the other one. like the other one. Okay, what you don't need to do is you follow the same principle. You take squares like you did in case 1. So error in z over z all square. Okay, just follow it. Follow it. Okay, pardon. There's error in a over a all square plus error in b over b all square plus error in c over c all square. No, that's just it. Just take the root sum of squares, follow the same principle like this. Now for case 1, addition and subtraction, you just add for maximum error. For standard error, you take the root sum of square. Okay, you're not taking any denominator for addition and subtraction, except you're given multiplication and division. And you take the root sum of squares. Alright, you just follow these formulas and blast it. Okay, now case 3. Alright, we go to product, quotient and power. Case 3, products, quotients and power. Okay, say we have a to n, b to m, and c to y. Okay, the maximum error, maximum error it's just a error z over z. Now the quotients, the powers. Alright, powers u n. Okay, error in a over a. Okay, plus, now be careful not to forget the powers. Alright, be careful not to forget the powers. Alright, plus y error in c over c. Don't forget to include the powers here. Okay, don't forget to include the powers for this. Now for standard error, it's more or less the same thing, just a tweak in the formula. Okay, so for standard error we have z of z all square. Now careful, we have n squared a over a. Okay, squared. Now all squared also, don't forget that. M squared b over b all squared. Now don't forget squares, and please don't confuse one for the other. Alright, so this is pretty much it. Okay, it just that's the way you solve, you do this, and everything will be fine. Okay. Okay. And what you need to do is you don't need to rush when dealing with errors. Just be careful, know the rules, formulas, practice more and more, and you'll be fine.